Hello class, this time I will be discussing the topic leveling. So, by definition, it is an art of determining the relative height of different points on, above, or below the surface. The main goal or the objective of leveling is to find the elevation of any given point with respect to some assumed reference line, which is called datum, and to establish point at required elevation with respect to datum. So, in leveling, kasunod na to nung process sa pagsasurvey natin after we have conducted the traverse. So, once we already determined the stations and distances in the traverse, so all we need to do now is to identify the elevations on each stations. Diba? Kasi dun sa traverse, we identified there the bearing of the line for each station, and as well as we also determine the coordinates. So with respect to the data that we have already determined in the traverse, we only have data along the horizontal plane. But how about the values for the vertical plane? So here, nagmamatter na ngayon ang use of leveling instruments and ways of determining the elevation for that particular data required. So here are the terms used in leveling. We have the level surface, or the surface parallel to the mean spheroidal surface of the Earth. Okay. Then we have the level line, or the line lying on level surface, the horizontal plane, or the horizontal plane through a point is a plane tangential level to surface. You also have horizontal line, which is a straight line tangential to level line. So as you can see here on this picture, once we conduct leveling, let's say here we have two stations. Okay? Doon natin ilalagay yung ating stadyarad. Okay? So, here, we have station A, which is this one, and station B, as we have determined when we are conducting survey for that traverse. Now, for leveling, we simply put the surveying instrument, which is the auto level, in between these stations. Pwedeng sa midpoint or at any point in between that direction on the line or the course of the two stations. So the reading on the leveling rod, okay, when we take a reading from the instrument here, okay, when we take the reading at point A, which is the station or the initial station, that's what we call the backside. For the reading on the level rod for the next station, which is station B, we call that the foresight. So as you can see here, we put the plus and minus sign, since these values will be these signs for the values that we have determined on the level rod using the leveling instrument. We will use this sign conventions later on when we conduct differential leveling. So, other terms used are the datum, or an arbitrary level surface from which elevation of points may be referred. So this the datum serves as the reference surface, or reference level surface in determining the elevation of a station. So usually the datum has a value of elevation of 0 meters. Okay, because that serves as the reference surface parallel to the surface of the Earth. So as you can see here, all we need to do is to determine the difference in elevation from the datum, okay, to that station in order for us to determine the elevation at point B as well as the elevation of point A. We have the mean sea level, or the average height of sea for all stages of tides. It is derived by averaging the hourly tide height over a period of 19 years. So the mean sea level, sometimes it is also used as a reference level surface in some surveys. While the elevation or reduced level surface, it is the height or depth of any point above or below any datum. So, yun na nga. If we have the stations, the value of the difference, or the value of the height from the datum of that station is what you call the elevation. So, other terms used, we have benchmark, or it is a fixed reference point of known elevation with respect to datum. Since the datum is not usually located at the surface of the earth, we have some reference points, or reference landmarks, or reference objects that we put on a location that serves as a reference point in conducting a survey. So that object is what we call the benchmark. Okay, and we have the line of collimation, or the line joining the intersection of crosshairs of diaphragm to the optical center of object glass and continuation, and it also known as the line of sight. So yun, kung ano yung nakikita natin sa ating instruments, sa ating level. So that is called the line of collimation, or the simply the line of sight of the instrument. So if I put here the instrument, so whenever I look at the instrument, okay, so kung ano yung tumama dun sa crosshair na meron dun sa ating instrument, okay, so yung pinoproject na line on matatamaan ng sight ng ating instrument ay yung ating line of sight, which is also called the line of collimation. Height of instrument, it is the vertical distance from the line of collimation to the datum. So usually sa differential leveling, the height of instrument is simply the elevation. Okay, when I have the instrument here, it is simply the elevation of the line of sight on where I put the instrument. Okay, kung saan ko sinet up yung instrument, it is required for me to determine what is the elevation at that point, because it is necessary in solving the elevation for each station that we have to determine. So I said it already, the backside is the staff reading taken at known elevation. It is the first staff reading after setup of instrument, or simply if this is the first station, the second station, station A, station B, I put the instrument here right after station A. So the rad reading on station A is what you call the backside, while the foresight is the last staff reading taken, denoting the shifting of the instrument. So when I shift our instrument, okay, to station B, so the instrument reading there is what you call the foresight. Okay, just like going forward and going backward reading for backside, and forward reading for foresight. So change point, TP, it is a point on which both fore and backside are taken. So here are the instruments used for leveling. We have the level and the leveling staff. Okay, so yan lang yung required sa leveling. So here are the types of leveling. We have the dumpy, tilting, Y, and we have the automatic level, which we have that instrument on our school. So we use usually automatic level in conducting differential leveling. And the leveling staff, it is also called as the rad or uh, leveling rad. Um, and they have different designs, but they will give you the same values for the differences in elevations for backsides and foresight values. So benchmarks. Let's talk about benchmarks. It is a point of known elevation, and it is usually used by geodetic engineers in conducting surveys. So here are the types of benchmarks. We have the permanent benchmarks, we have arbitrary benchmarks, we have GTS, we have temporary benchmark. So what are these? So this is an example of a GTS benchmark, which is used by geodetic engineers. So the geodetic engineers are the one who made or identifies and set up this type uh, of object on a selected location. So usually sa ibang bansa, maraming ganyan. But here in the Philippines, itong mga sample ng benchmark na meron tayo. So, this is a benchmark by NAMRIA. So, as you can see, for that particular location, it is stated there, the station name, the elevation, as well as the coordinates. So, that's how important a benchmark is, because it serves as a reference point for any survey that to be conducted. So, another benchmark, permanent benchmark, Walt Disney. So, what are the methods of leveling? We have barometric, trigonometric, and differential leveling. We also have inertial leveling. But here in this lecture, I will just be discussing to you about the differential leveling. Okay? So, for differential leveling, okay, the solution in determining the height of instrument given we have a known elevation. So it is important that for the initial station or for the first point, we should start at the benchmark because it has a known elevation. So to compute the height of instrument or the elevation at the line of sight of the instrument, we simply add the backside or the rad reading at the benchmark to the known elevation on the benchmark. So after that, to determine the elevation of any unknown point or the succeeding station, okay, right here, say this is point A, point B. So simply have a rad reading for the foresight and subtract that value to the height of instrument or the elevation at the line of sight of the instrument, so that we will be able to determine the elevation. Okay? So, after that, for the succeeding stations, just simply set up again the instrument. So let's say it's the point A, point B, or the benchmark BM, BM1, TP1, okay, because the change location. Say, so, ganun lang, sa leveling, you will set up again the instrument in between the stations. So if this is the next station or the next location for the elevation to be determined, let's say point C, so take a rad reading again for the backside. So the backside value naman para sa point B ay nandito. Then take the foresight reading and that's it. You can now identify the elevation at point C using this formula and so on and so forth. So in differential leveling, since there are numerous data that we will be able to collect, it is important to show our values or our data in a tabular form. So for us to be organized, let's make a table of the stationing or the benchmarks or TP. Then you plot there all the backside for that station, and you plot all the foresight for that particular station. Then put another column for the height of instrument and another column for the elevation for that station. Okay, sample. Okay, so an example here. So we are required to determine the elevation at TP1, TP2, TP benchmark number 6. So we have backside and foresight values of 3.75, 2.62, 6.09, 5.07, 7.43, and 1.58. So all we need to do is to put that on a table. So ito na yung table natin for each station that has the data for backside and foresight. We have a given elevation for benchmark number 3 of 100 meters or 100. So solution for the height of instrument for each course. Solution or the formula is simply add the backside to the elevation of the previous station. So if this is your instrument right here, just add the backside reading. So for the height of instrument here at benchmark number 3, add 100 to 3.75, since height of instrument has the formula of the elevation of the benchmark plus the backside reading. For the elevation formula, elevation for the next station, the height of the instrument is to be subtracted by the foresight. So back here, 100 plus 3.75 is 103.75. So here, 103.75. Next, for the elevation of TP1. TP1 elevation, simply subtract the height of instrument 103.75 minus foresight of 2.62. Okay, 2.62. So 103.75 minus 2.62, we have 101.13. Then put that in the table. For the next height of instrument, at this point, the height of instrument is equals to the elevation of the previous station right here for TP1, which is 101.13 plus the backside reading of 6.09. So add 6.09 to 101.13, 107.22. Okay. Next, TP number 2, elevation. TP to elevation is 107.22 minus the foresight of 5.07. Okay, 102.15. Then here 102.15, 107.22. Height of instrument for this location here, add again Okay, add 102.15 to the backside reading of 7.43. So 102.15 plus 7.43, 109.58. For the final station, which is TBM number 6, sorry, this is benchmark number 6. Subtract again the foresight. 109.58 minus 1.58. So just be careful in solving the height of instrument and elevation for each station so that we will not have an error on the final station. So subtract that, we have a value of 108 for the elevation. So that's your final answer, 108 for the benchmark, for the elevation for the final station, this one. Okay, so another problem, we have here benchmark number 12, benchmark number 13, and benchmark number 14. And in between those benchmarks, we are required to determine the elevation also for each change station or TP. Okay, so it's required here to determine the benchmark number 14 elevation. So we'll not be able to determine the elevation for that station without solving first the elevations for each station before that station. So same solutions, same formula for the height of instrument. Okay, height of instrument is equals to the elevation to be added by the backside. And after determining the height of instrument, determine the elevation by subtracting the height of instrument by the foresight. So that's all. 209.65 plus 4.64. Okay, it's equals to 214.29. 214.29. Then subtract the foresight for the next station, which is 5.06. So answer, subtract by 5.06 is equals to 209.23. Then add again the backside of 5.8, 215.03. Then subtract 5.02, 210.01. Then add 225, 212.26. Subtract 5.85, 206.41. Add 6.02, 212.43. Then subtract again 4.34. Sorry, we have 208.09. Then add 8.96, 217.05. Then subtract 3.22, 213.83 plus 8.06 is 221.89 minus 3.71 to 18.18 plus 9.45 227.63 minus 2.02 225.61 plus 12.32 237.93 and last subtract by 1.98. The final answer is 235.95. That's your final answer. 235.95 is the elevation for benchmark number 14. Okay? So that's how you solve the elevation for each station using differential leveling. Thank you for watching.